through the relay infrastructure. So the client has a couple components. We have a NAT client, which is like an agent that runs on like my Mac OS, which is in this demo is going to happen. I have packet filter, and the original packet goes straight into packet filter. Packet filter is part of Mac OS, and it will redirect to a specific port for both UDP and TCP to the NAT client. Now, in order for NAT to be able to know where the destination is, it uses a flowmon in order to monitor the original packets, and that's done only on initial connection, so only on the initial first packets that come in, and once that's established, it doesn't deal with the monitoring from that perspective anymore, but it allows us to get the actual destination of where it's really meant to go, even though we're using to redirect ports. Now, the traffic does flow through using the relay protocol, and that goes to any number of relays, and the relays are fully meshed, so it doesn't really matter which relays we go to. But in this example, in this demo, I'm going to use relay US East 2, and I'm going to use US East 2 for the server egress side as well. And in fact, for this demonstration, I'm going to run the server egress natter and server mode. I'm going to run that on the relay US East 2 server, just because I don't want to waste a whole bunch of other instances out there. But that server will then make a native connection, or the relay or the server side of the natter process, that will make a connection outbound to the actual server. And the actual server, just like the client, is communicating directly through IP. So what we have here are several windows. The top two windows are the server, and it's an EC2 instance that runs in Amazon. It's a complete different server. So kind of shown here, we have the client, which is going to run on my laptop, and the server that runs below, which is the server egress, that is an EC2, that's going to be the relay, and then the actual server itself is going to be an EC2 instance. So between my client and the server, it's going to be native IP, and I can do both UDP and TCP, and that's what we're going to show here. So I'm going to run two connections to my server, and I'm going to start up a UDP listener, which is an echo server that just runs UDP. So it's not going to do anything other than just UDP echo responses. So a connection will come in, it'll listen to port 5004, and when a connection comes in or packets come in, it's going to just echo responses back to them. And we're going to run the same thing on the left-hand side, but this is going to be for TCP. So this is TCP, and anything that we receive will echo back. The next window, the dark black window, is my client side. That runs on my laptop. And this is going to listen to and monitor and redirect ports 5004 and 9000, but we're going to only focus on 5004. And then I need to run a server side. So both my client and server are going to the same relay. I'm just using the IP address for my client and the FQDN for the relay. Now, before I start the server egress side of Natter, I'm going to show a little test here. And you can see down below we have 3 different clients. So these are native clients using Netcat or Telnet. And these clients will natively communicate transparently through the relays. So the 2 black windows in the middle, they'll communicate. Now notice the first connection where it says hi from UDP does not work. And that's because I don't have the server egress running yet. So I just want to illustrate that it does not work, obviously, if we don't run the egress side of this, which is really just a subscriber to subscribe to the destination IP packets. And we use CIDR ranges to do that subscription. And we're going to focus specifically on this EC2 instance here. So the 3.145.99.150, that's the one we're going to focus on. So now if I say, again, from UDP, it does make it all the way through. So the server side, which is an EC2 instance running only Python, standard socket library, whatever, it's not relay enabled, it gets the packet and it sends back a response, and that response comes back. And we can see that in the debug output, but we can also see it down in the left-hand client side where it actually did get an echo response. So let's try TCP now to do this as well. And we're going to just do telnet for TCP. So it's telnet application. And then again, the Python script on the other side is just going to listen for TCP connections coming in. Now, when we first make a telnet connection, it does get established, but it doesn't actually go anywhere other than the client because I haven't sent any data. So as soon as we send data, that's when the other remote end or the egress side of the NAT process will actually create the connection. And it's actually, if you see here, it's coming from this 3137, 141, 105. That's the relay. That's where we're running the server egress process, or the NAT process. So it sees that IP address. That's why this is referred to as NAT, is because my client address is actually being translated. And my client's coming from, I'm actually using Cisco VPN, so I'm coming from Cisco's network for this. But we can see we are maintaining independent. So the bottom three windows here, the flows are independently maintained and they are symmetrically bidirectional, just as you would if you had an IP connection directly between the two client and server. It's exactly the same. It works bidirectional through the relay infrastructure. And we can see that we're not cross-talking here. So there isn't, between the flows, we don't accidentally cross-talk anything and send stuff to another flow that should have not received the data. So it is maintained at the flow level. Thank you for that. And I'll show this whole thing with media very soon as well. Media does work. It's just a little bit more to do the media recording.